All right, guys, so in this example, we've got a box that contains the following letters. So pretend that these are like Scrabble letters. Each of these letters are on like a tile or something. And so the question says, what is the probability that the event TEACH, so like I draw a T, and then I draw an E, etc., is obtained in that order if 5 letters are drawn one by one. So these letters are all in a bag or box or whatever. I stick my hand in, I pull one out. What is the probability that that's a T? And then I stick my hand in, I pull one out. What's the probability that it's an E, etc., etc. So the first scenario is with replacement, meaning I take a letter out, I look at it, and then I put it right back in. And I'm looking for T, E, A, C, H. Now, the probability of T is going to be 1, 2, because there's 2 T's, out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, because I've put that letter back in, I still have 11 letters back in the basket, or the whatever it is. Now, what's the probability of an E? Well, there is just one E out of 11. What's the probability of drawing an A? 1, 2 out of 11. And then I'm going to continue the same thing. C's, 1 out of 11. And then H, 1 out of 11. And so now I am multiplying all of those because I'm looking for the probability of a T and an E and an A and a C and an H. I'm not looking for the probability of any of those letters, T or E or A or C or H. I'm looking for all of those to happen. And so that theorem we looked at on the last video, these are all independent events. The probability of them both happening is going to be to multiply all of those events. So when I multiply that, multiply your fractions straight across the top and straight across the bottom, I get 4 out of 161,051. You could leave it like that, or you could give the decimal version, which would be a really small number, or 0.0, 4 zeros, 2, 4, 8. So not very likely. Probably have a better chance of winning the lottery. All right, letter B, without replacement. So now that means I'm going to draw a letter out, and then I'm not putting it back. All right, so I'm still looking for the same probability, TEACH. T, well, the same as before, there's 2 T's out of a total of 11. Now, with the E's, I have drawn a letter out, and I did not put it back, so now there's only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters left. And then there is 1 E. Now, if the E was drawn, there'd still be this probability wouldn't change. We don't have to do the tree diagram where we're like looking at if I do this, if I do this. We're just talking about the probability as a whole. A, I've drawn another letter out, so now I only have 9 letters left in the bag, but there's still 2 A's. I've drawn another letter out, so there's only 8 letters left in the bag, and there is 1 C, and I've drawn another letter out and not put it back, and so I have that. Now, just like before, multiply straight across the top, straight across the bottom. And you get, when you multiply the top, you get 4. When you multiply the bottom, you get 5, 5. So 55,440. And that does simplify to 1 over 13,860. Or you could do the decimal version, which would be another really small number, 0.592. I don't care which one you do, decimal or fraction. Make sure, though, with your fractions, if you are going to do the fraction, that you do reduce the fractions before before your final answer.